They promised power and reliability, but delivered disaster. Let's count down the 10 worst car engines ever made. Number 10, Nissan QR25DE 2002 to 2006. At first glance, Nissan's 2.5-liter QR25DE looked like a modern step forward, lighter, cleaner, and more efficient than the iron block engines it replaced. With 175 to 180 horsepower on tap, it promised smooth performance for daily drivers and weekend racers alike. But beneath the spec sheet was a time bomb of engineering oversights that would haunt Nissan's early 2000s reputation. The worst offender was its catalytic converter design. Inside the exhaust manifold sat a ceramic honeycomb meant to filter emissions. But in the QR25, that ceramic core often broke apart under heat and vibration. Tiny shards were sucked back into the engine through the exhaust valves, scoring the cylinder walls and ruining compression. Some engines burned an entire quart of oil every few hundred miles before owners even realized what was happening. Then came the timing chain stretch, a seemingly minor issue that could turn catastrophic overnight. The chain's tensioners wore prematurely, creating a rattling sound that most drivers ignored, until it skipped a tooth, causing misfires or total engine failure. Even dealership techs joked that the QR25 had its own built-in countdown timer. Combine that with overheating problems from thin head gaskets and warped aluminum blocks, and you had an engine that could fail from multiple angles. For many owners, a car that should have lasted 200,000 miles barely made it past 80,000. Nissan quietly redesigned the engine by 2007, but by then, the QR25DE's legacy was already sealed as one of the most fragile four-cylinders of its era. Number 9, Chrysler 2.7-liter V6, 1998 to 2010. The late 90s, Chrysler 2.7-liter V6 was supposed to be a symbol of innovation, a high-tech, all-aluminum engine built for smoothness and efficiency. But what it delivered instead was one of the most catastrophic reliability disasters in modern automotive history. The problem started deep inside the block. Engineers designed an extremely narrow oil passage system to keep things lightweight and compact. In theory, it made sense. In reality, it created an engine that barely lubricated itself. Combine that with high operating temperatures and long oil change intervals, and you got the perfect recipe for sludge buildup, a thick tar-like residue that starved the engine of oil until it seized completely. Owners didn't see it coming. There was no warning light, no clear symptom, just a sudden knock, a puff of smoke, and then silence. By the time most drivers realized something was wrong, it was too late. Even regular oil changes weren't enough to save it. Mechanics reported pulling apart 40,000-mile engines packed full of sludge, calling them Black Death blocks. The water pump was another weak point. It was mounted inside the engine and driven by the timing chain. When it leaked, coolant mixed directly with the engine oil, accelerating sludge and corrosion in one devastating combo. A repair that should have cost a few $100s often turned into a complete engine replacement. For a decade, Chrysler stood behind the design, insisting maintenance was to blame. But by then, the damage to their reputation was irreversible. The 2.7-liter V6 became infamous among mechanics as an engine you could ruin just by driving it normally, a mechanical ticking time bomb that helped sink Chrysler's image in the 2000s. Number 8, the Peugeot and BMW 1.6-liter THP Turbo 2006 to 2014. When BMW and Peugeot announced a joint engine project in 2006, expectations were sky high. The idea sounded bulletproof, a turbocharged 1.6-liter that would power everything from sporty minis to sleek Peugeots and Citroëns. On paper, it was a masterpiece, compact, powerful, and fuel efficient. In reality, it became one of Europe's most infamous engineering headaches. The engine, known as the Prince or THP, suffered from a chain of failures. Literally, the timing chain was undersized for the job, and its tensioner design was so poor that owners often heard a metallic rattle at startup, sometimes within 20,000 miles. Left unchecked, it could jump timing entirely, bending valves and destroying pistons. Then came the carbon buildup, a plague of early direct injection engines. Without fuel washing over the intake valves, soot collected rapidly, choking airflow and reducing power. Cars that once felt punchy at 170 horsepower suddenly struggled to idle smoothly. Mechanics described the fix as open heart surgery, requiring full disassembly just to clean the valves. If that wasn't enough, the high-pressure fuel pump, critical for maintaining boost, was prone to premature failure, leading to random stalling or limp mode nightmares. Add fragile turbo seals and constant overheating issues, and the THP became an alphabet soup of repairs no owner wanted to spell out. What makes this one sting is who built it. BMW and Peugeot had decades of engineering experience, yet their collaboration produced an engine so flawed it led to multiple redesigns and class action lawsuits. Even loyal Mini Cooper fans eventually admitted it. Number 7. Ford 3.8-liter Essex V6, 1982 to 2004. Ford's 3.8-liter Essex V6 was meant to bridge the gap between fuel economy and V8 performance. Debuting in the early 80s and powering everything from family sedans to Mustangs, it was built on optimism and ended in frustration. What started as a dependable midsize engine turned into a 20-year headache for owners and mechanics alike. The biggest flaw was in its design, an aluminum cylinder head bolted to a cast iron block. The metals expanded at different rates when hot, creating a war zone of pressure inside the engine. The result? Head gasket failures, so frequent that they became synonymous with the Essex name. Owners complained of coolant in their oil, white exhaust smoke, and engines that overheated at the worst possible time. Ford tried to fix it with thicker gaskets and new bolts, but it barely helped. Even properly maintained engines failed around 70,000 miles. Dealerships were flooded with warranty claims, and by the mid-90s, Ford was quietly paying millions in repairs. A class action lawsuit soon followed. But the problems didn't stop there. The timing cover was another weak spot, prone to leaking coolant into the oil pan. Add intake manifold gasket wear, and you had an engine that could literally drown itself from within. Mechanics nicknamed it the self-destructing 6. Despite decent torque, around 240 pound-feet, the Essex was always let down by its reliability. Ford used it for over 2 decades, but its legacy is one of frustration. The 3.8-liter was a perfect example of how one bad engineering decision, mixing aluminum and iron, can turn an otherwise capable engine into an industry punchline. Number 6. Mercedes-Benz M272 V6, 2004 to 2008. Mercedes-Benz has built its reputation on precision and engineering perfection, but the mid-2000s M272 V6 proved that even the 3-pointed star can stumble hard. On paper, it was a modern marvel: lightweight aluminum construction, variable valve timing, smooth delivery, and solid fuel efficiency. But under the hood, one small part turned this engine into one of the most expensive mistakes in Mercedes history. That part was the balance shaft gear, a tiny hardened metal gear buried deep in the engine's valley. In early versions of the M272, it was made from a material too soft to handle long-term stress. As the teeth wore down, the engine timing began to drift, triggering a dreaded check engine light and a wave of expensive repairs. The fix wasn't a quick one. It required tearing the engine apart just to reach the gear, often costing $5,000 to $7,000 in labor alone. Owners describe the experience as owning a luxury car that punishes you for driving it. Dealerships often blamed maintenance habits until Mercedes finally admitted the issue and issued a partial warranty extension, but not before thousands of loyal customers were left stranded. And that wasn't all. The M272 also suffered from intake manifold swirl flap failures, tiny plastic valves that cracked and jammed, creating air leaks, power loss, and more repair bills. For a brand that sold itself on the best or nothing, this engine became a rare case of the latter. Number 5. Subaru EJ25, 1996 to 2011. For years, Subaru built its image on reliability, ruggedness, and the promise that its boxer engines could outlast the cars around them. But the EJ25, a 2.5-liter flat 4 that powered nearly every Subaru from the late 90s through the 2000s, became infamous for a flaw that would haunt the brand for over a decade: head gasket failure. The design of the EJ25 seemed brilliant on paper. Its low center of gravity improved handling and traction, perfect for Subaru's all-wheel drive lineup. But that horizontally opposed layout came with a hidden curse. The head gaskets sat on their sides, constantly exposed to heat and vibration. Over time, the gaskets would degrade, allowing oil and coolant to mix. The result was white smoke, overheating, and the smell of burning coolant seeping through vents. Subaru tried to fix the issue repeatedly, switching from composite gaskets to multi-layer steel and even adding special coolant conditioners. But none of it fully solved the problem. Mechanics could almost diagnose the issue by ear. A bubbling coolant tank or ticking noise from one side meant another EJ25 was about to blow. To make matters worse, the open-deck block design of early versions offered poor support around the cylinders, amplifying the stress on the gasket. Even after factory updates, many engines failed again within 60,000 to 100,000 miles. Owners joked that the Subaru experience included a head gasket replacement every few years. Number 4. Porsche M96 Flat 6, 1998 to 2005. When Porsche introduced the M96 engine in the late 1990s, it marked a turning point for the brand. It was their first mass-produced water-cooled flat six, designed to modernize the 911 and lower manufacturing costs. But what was meant to be an engineering leap forward became one of the most controversial engines in Porsche history. The heart of the problem was a tiny component buried deep inside the engine, the intermediate shaft bearing, or IMS bearing. It was responsible for keeping the timing system synchronized, and when it failed, the results were catastrophic. The bearing would disintegrate, throwing metal shrapnel throughout the engine and destroying it in seconds. There was no warning, no gradual failure, just a sudden, complete mechanical death. The IMS issue wasn't rare, it was epidemic. Some estimates suggest up to 10% of early M96 engines failed, a nightmare for owners who thought they were buying German precision. Porsche quietly revised the design several times, but even fixed engines remained a gamble. The repair, if caught early, cost several $1,000s. If not, owners faced $15,000 to $20,000 engine replacements. But the IMS wasn't the only flaw. The M96 also suffered from rear main seal leaks, porous blocks, and cylinder scoring that left owners chasing oil consumption issues for years. For a brand built on motorsport perfection, this was humiliation. To this day, Porsche forums are filled with debates, horror stories, and $2,000 IMS retrofit kits promising salvation. The M96 became the engine every Porsche owner fears, and a painful reminder that even the greatest sports car company in the world isn't immune to catastrophic engineering errors. Number 3. GM 3.4-liter V6 1993 to 2005. By the 1990s, General Motors had perfected the art of reusing engines across half its lineup, and the 3.4-liter LA1 V6 was everywhere. It powered sedans, minivans, and even SUVs. On paper, it seemed bulletproof, a simple pushrod design producing around 180 horsepower and enough torque for daily driving. But simplicity doesn't always mean reliability. The 3.4 liter's downfall came from one critical weakness: its intake manifold gasket. Made from cheap plastic and rubber materials, the gasket couldn't withstand the constant expansion and contraction caused by engine heat. Over time, it would crack and begin leaking coolant directly into the oil passages. That deadly mix created sludge that quietly destroyed bearings, camshafts, and lifters from the inside out. The problem was so widespread that mechanics started calling it GM's coolant curse. Many owners didn't even know their engines were failing until the oil cap looked like it had mayonnaise on it, a telltale sign of coolant contamination. By then, it was already too late. To make matters worse, GM used the same fragile gasket design on multiple engines, spreading the problem across their brands. The company eventually introduced a revised metal-reinforced gasket, but millions of vehicles were already out there quietly eating themselves alive. Number 2. Cadillac Northstar 4.6-liter V8 1993 to 2011. On launch, the Northstar looked like America's answer to Mercedes and BMW, an all-aluminum, high-revving V8 with silky power and a luxury badge to match. In practice, it became a money pit that terrorized owners and dealership techs for nearly 2 decades. The fatal flaw lived in the head bolt threads. Cadillac used long bolts threaded into soft aluminum. After enough heat cycles, those threads pulled out of the block, the head lost clamping force, and the head gasket let go. Symptoms started small: mysterious coolant loss, a sweet smell, a temp gauge creeping up, then spiraled into combustion gases in the cooling system and chronic overheating. The fix wasn't a Saturday repair. Shops had to drill and install steel inserts in 20-plus bolt holes with the engine out of the car. It was invasive, expensive, and often exceeded the value of the vehicle. Then came the leaks. The Northstar was infamous for seeping oil from the case half seal, valve covers, and rear main. Many owners thought they'd parked over a crime scene. Add in coolant crossover gasket failures, and the brand's long-life coolant turning nasty and neglected systems, and routine maintenance could snowball into multi-$1,000 teardowns. Even engines that didn't overheat could burn oil thanks to carboned rings and aggressive PCV behavior. Normal, according to some manuals, but infuriating in the real world. Cadillac did revise hardware and procedures over the years, but the reputation stuck. For every thrilled test drive, there were 3 horror stories about a Northstar that went from smooth to scrap in a single summer. Number 1. Oldsmobile 5.7-liter diesel V8, 1978 to 1985. Few engines in history have done more damage to consumer trust than General Motors' infamous 5.7-liter diesel V8. It was supposed to revolutionize the American automotive landscape, a fuel-efficient diesel built for the gas crisis. Instead, it became one of the most notorious engineering failures ever sold to the public. In the late 70s, GM rushed the project to market. Instead of designing a new engine from scratch, they converted a gasoline V8 into a diesel by strengthening a few parts and calling it a day. The result was an engine that simply couldn't handle the immense compression that diesels require. Head bolts stretched, head gaskets blew, and blocks cracked under pressure. Owners reported catastrophic failures within the first 20,000 miles, sometimes even sooner. Worse yet, the engine was paired with weak fuel injection systems and poor quality fuel filters, which led to clogging, stalling, and injector pump failures. Once it failed, the repair costs often exceeded the value of the car itself. The damage wasn't just mechanical, it was reputational. Thousands of buyers who had trusted GM's new diesel revolution were left stranded, furious, and vowing never to buy American again. The fiasco didn't just ruin GM's diesel ambitions, it tainted the perception of diesel passenger cars in the US for decades.